Okay, today we're going to be talking about slope and perpendicular lines. This is section 10.2 in geometry and 2.2 in math 3. So what do we need to know in order to prove lines are perpendicular? Well, if we know their slopes, we can prove whether or not they're perpendicular. And the way we would do that is there's two things to think about, two ways to do this. The first is if their slopes multiply to -1. So for example, if one line had a slope of 2/3 and the other one had a slope of -3/2, if I multiply those together, I get -6 over +6, which becomes -1. That's that's one way to prove lines are negative. That is one way to prove that lines are perpendicular. If I look at those two slopes, however, you can actually figure out that they're perpendicular by noticing that they are what are called negative reciprocals. Reciprocal means I flipped the fraction over, so 2/3 became 3/2. And negative means one is positive, one's negative. So if they're negative reciprocals, they're different signs, and in one of them the fraction is flipped upside down. There's another way to show that they're parallel. So let's take a look at example 1. Using the slopes to classify the figures by right angles. So if we want to show that this this quadrilateral, 4 sides, is a rectangle, we're going to do that by first finding their slopes. So we can do this with the coordinates. For example, for AB, remember our slope formula is y2 minus y1 over x2 minus x1. So if I want to plug in AB has the coordinates 3, 2, so that's my x and y, minus minus. A has the coordinates -3 for x and -1 for y. And I would simplify those. So that becomes plus, plus. I'm looking at 3, 2 plus 1 is 3, 3 plus 3 is 6. 3 over 6 is 1/2. I'm going to pause while I answer that phone. Okay, I'm back. So the slope is 1/2. I can do that for all 4 sides, side AB, side BC, CD, and AD. You could also find the slope by counting rise over run. So for example, that one we just did, AB, I would count 1, 2, 3. So it rises 3. And I would count the run, 1, 2, 3, 4, 5, 6. It runs 6 in the positive direction. 3 over 6 is 1/2. So you get the same slope either way, either by counting or using the slope formula. So now let's take a look at BC. Well, if I look at BC, my run from B to C is down 2. So that would be a -2 and over 1. Now that does reduce to just -2. I'm going to leave it as a fraction though because it's a little easier to analyze. So let's compare those two sides of the sides of the quadrilateral, AB and BC, and see if what we can figure out about that angle B. Well, AB had a slope of 1/2. BC had a slope of -2 over 1. If I look at those, they do appear to be negative reciprocals because the 1 moved from the top to the bottom, the 2 moved from the bottom to the top, and the first one is positive, the second one is negative, so they're different signs. So that tells me they're perpendicular, but let's double check using our multiplication rule. If I multiply straight across, 1 times -2 is -2, 2 times 1 is +2. -2 divided by +2 is -1, which is what I'm looking for. Angle B is a right angle. I would check that for the other angles and notice that all 4 are the same. So here's another little shortcut that we might notice. When you work out the rest of them, which the book has done for us, we get 1/2, 1/2, so those are the same. If those two lines are parallel, if AB...
Will the following teachers please call...
Sorry, that was another interruption. Those are both 1/2. So I don't have to do the multiplication of taking CD slope and multiplying it by BC. I'm going to get the same answer because it's the same number. So that's a right angle as well. And the same thing here. If I look at AB and DA, well, I've already multiplied 1/2 by -2 and figured out that they are negative reciprocals, that those lines are perpendicular, so I figured out all 4 angles are perpendicular. That's where we're going to end for this video. I'll see you guys in class. Have a good one.